Hi everyone, this is a video for geometry, Math 240/341, and what I'm gonna attempt is a construction which actually proves the Pythagorean theorem. So here's the idea. Let's say I have a right triangle. Let's say I have one that is 4 on this side, 3 on this side, with the right angle, and let me draw the hypotenuse. Call the hypotenuse C. Now, what we're trying to do is show that the square of C has to exactly equal 3 squared plus 4 squared, right? Which is kind of cool because in this case, 3 squared plus 4 squared is 25. So we're trying to show that C has length 25. And we're trying to do it in a proof. But here's kind of the idea. We're talking about not the lengths of the sides, but the squares of the lengths of the sides. So what you actually do is you make these squares. A square whose side length is 3. Now I'm just using 3 and 4, but this method will work in general. Okay, so this guy's 3 squared. And now if I do 4, this guy here is 4 squared. And then what you do is you cut these guys out. This is a really nice activity that you can do with kids. Okay, there's my 4 square. And here's my 3 square. Now, fortunately, when the class is taught face-to-face, I have everyone do this in class. But, you know, hey, what can you do? And what you do is you put the squares side by side. Well, let's do it. It's not perfect, but you know what I mean. And side by side. And tape them together. So I'm making a single shape that is the combination of these 2 squares. Let's do it on both sides so it's nice and complete. Paper tip. Do it correctly, nicely. Always takes me a couple tries to make it look good. And maybe even, I like to kind of do the wrap around here. Okay. So I get this guy, which is just 2 squares cut together. And now here's the idea. However long the one of them is, the short one, but this will actually work if they're both the same size too. It's kind of fun. But you take the short one and you start from this end and you back up that much. So I'm finding this spot here. Okay. So, and find that point there. Okay. And then I make 2 lines from that point up to this corner, and then from that point to the other top corner. Okay. So again, let me think, what did I do? So notice I had a 4 square and a 3 square. On the longer one, I started on the far end and I backed up the length of the smaller one. So that this triangle here that I made is actually my original. Sort of see that? It's a 3 by 4 right triangle. Okay. And the other thing to notice is, look, this triangle here is also a 3 by 4 right triangle. Now, why is that? Well, I've made it so this guy has length 3. The whole thing has length 3 plus 4. So this, which is 7. So this has to be 7 minus 3, or the 4. So I know it's obvious with these particular lengths, but I'm trying to explain it in a way that'll generalize to any number. Okay, so what you do now is you cut off these two triangles. And that's why I had to tape it together nicely, so that when you cut it, it doesn't just all fall apart. Okay, so now I have 3 pieces. I'm going to stick them together. It's the 2 squares that have been taped together. And now I have these 2 triangles. Okay, what am I going to do? Well, I'm going to do, this is called a dissection, actually, when you take things together and you cut them up and you rearrange them and stick them back together. So notice I'm not throwing away any pieces, so it conserves the area of the pieces I started with. Another way to think about it, and this be helpful when we do transformations, is this is a slide. So I can take this guy here and just slide it up and it matches. And I can take this guy here, slide it up, and it matches. So I've taken the 2 triangles and I've just slid them, which doesn't change their area or anything. And now let's take this together. So let's see if I can do it fairly accurately. A little bit more just so it looks nice. Kind of overdoing the tape here, but that's okay. I want it to look nice. Okay. So notice this thing here has area a squared plus b squared. Why is that? Because I started out with an a square and a b square, and I just cut them up and moved them around. I didn't throw away any area. So this is still a squared plus b squared. But now notice what else it is. What have I made with my a squared plus b squared? Voila. I've made a c square. Pretty cool, huh? Now you could check just physically, to show that these are all right angles. That really is a square. And you could show that these are all the same length, C. So you could show it right here visually, or you could prove it analytically. So I have this thing here is c squared, but it's also a squared plus b squared. So those two things must be equal. Pretty cool, huh? Okay.